Hello and good day everybody. Welcome again to another video lecture, and for today's video we would now be discussing about conditional probability. Okay, so suppose that we have this Venn diagram here whereas the circle on the left represents event A and the circle on the right represents event B. And for the whole area here, that is now our sample space. So when we say conditional probability, we are solving for here the probability of a certain event happening in the condition that another event should also occur or also happen. So suppose that in this Venn diagram here, so as you can see that we have events A and event B, and they also have their intersections, and in that intersection I would now be writing this as the intersection of A and B, or the intersection of B and A. So this is basically the same. Okay, so for conditional probability in statistics, this is often referred to as the what is the probability of B occurring or happening in the condition that A should also occur. So in another word, or in some of the books, if you would be reading this can also be read as the probability of B given A. Okay, so what is now our equation here? So considering this equation, what is now the probability of B happening considering that A should also occur? So from that, guys, what is now the events in B whereas A would also occur? So in other words, that is basically this area here, or the intersection of both of them. And from that, I can now say that in this probability, this is now the ratio of the number of this or of these events here, whereas it is now the intersection of A and B. So A in intersection with B divided by, okay, so divided by, if you can remember from our previous video lectures, that for probability, this is basically equal to the number of elements divided by the number in the sample space. But in conditional probability, we will be localizing it, that instead of us solving for it via the ratio of this particular event divided by the number of sample space, so we will now not make use of our sample space. Instead, we will only make use of the condition itself. Okay, so for our new sample space in this particular conditional probability, this is now our localized sample space. So with that being said, guys, if this is now our event, the intersection of both of them, our new sample space is that instead of us having the whole section for the sample space, we will only refer to this area here as our sample space. Okay, once again, this is now our equation. And since the intersection of A and B is also equal to the intersection of B and A, this can also be rewritten as the number of the intersection of B and A divided by the number of event A. Okay? So, another thing, if we would now be reversing this equation, whereas what is now the probability of A given B? So our equation is now equal to, so the number of the intersection of A and B divided by the number of our new sample space in this manner, and that is now the number of elements or the number of events in event B. And from that, guys, our event would still be their intersection, but for our new referred to sample space here, or for our denominator, it would now be this. Okay, so let us just have an example here. Okay, so in our problem here, a random sample of 200 samples are classified by gender and their level of education attained. If a person is picked at random from the group, find the probability that the person is male given that the person has a secondary education, and B, the person does not have a college degree given that the person is female. Okay, so in this situation, we already have our data here, and from this data, I will name male or the male events as M, For the female, I will be naming this as F. For elementary graduates, I will be naming them as E. For high school, H, and C for college. Okay, so for the first one here, we are to solve for the probability that the person is male given that the person has a secondary education. So by the way, guys, when we say secondary education, this just means high school. So once again, secondary education and high school is synonymous. Okay, anyway, so for letter A, again, we would be solving for the probability so that the person is male. So the person is male given that the person has a secondary education. So meaning that this is now our condition, okay? So our condition is that the male should be or should have a secondary education degree. Okay, so from that, this is now the condition. So H. Okay, so if you would now be referring our formula to what we have been deriving earlier, so this is now equal to the number of the intersection of M and H. We would now be dividing this by the number of our new sample space, which is the number of our condition, NH. Okay, so if you can memorize this formula, then good. However, I do not really memorize formula. Instead, it is better if you would just be understanding this equation right here. So in this equation, we would just be writing down the male high school graduates and just divide them by the total number of high school graduates. So once again, we would just be dividing by the male high school students or the male high school graduates by the total high school graduates, or simply this one here. So from that, what is now the intersection of male high school graduates? So from that, this is now equal to, so how many male high school graduates are there? So we have 30. So this is the intersection between M and H. So from that, this is 30. So what about for the number of high school graduates? So N, H, this is now equal to, so how many high school graduates are there? So that is now 30 plus 50. Thus, this is 80. So from that, the probability of M and H is now equal to, so substituting non-values, that is 30 divided by 80. So I think this is 37%, but I'm not sure. So let us just use our calculator here. So 30 divided by 80, that is now 0.375. So 0.375, or if you would be multiplying it by 100%, that is now 37.5%. Okay. So again, if you would now be totaling all of this, so the total sample space is 38 plus 45 plus 30 plus 50 plus 22 plus 17. So the total number of students here are 202 students. So this is now our sample space. But as you can see in our formula, we did not use of our sample space here. Okay. So again, that is for letter A. Okay, so for letter B, So for letter B, so I will just be erasing this first. So for letter B, it is said here that what is the probability that the person does not have a college degree given that the person is female? Okay, so from that, guys, so for letter B, we are now solving for the probability that a person does not have a college degree. So this is now our event. So does not have a college degree. And our new sample space or our reference is that it must be female. Okay, so if we are to write its equation form, what is the probability? So how can we write this in terms of symbols? So does not have a college degree. So that is basically C complement. So when we say C complement, it means that if this is C, Okay? If this is C, its complement would now be this one's here, which is not included in 22 and 17. Okay. So again, what is now the probability of C a complement in the condition that it must be female? So this is now our equation. So from that, once again, if you want to write it in equation form, this is now equal to the number of the intersection between the complement of C and female divided by the number of female. Okay? So the number of female, since this is now our condition. So from that, guys, the intersection between the complement of college and female is that, so in this case, this is college. Okay, this is college. So since we are to get the complement, it means that we are now getting these values here. That is for C complement. However, it must be female. So from that, guys, our event or the event that we will be making use here is just these two. So from that, this is now equal to 45 plus 50. Okay? So what about for the number of females? So that is now N, F. So how many females are there? So if I am to total the number of females, that is now 45 plus 50 plus 17. So looking at the calculator to your left, that is 45 plus 50, 45 plus 50 plus 17. So that is now equal to 112. So 112, 112. Okay, so substituting known values. So P, C prime, F is equal to, so substituting known values, this is now equal to 95. So 45 plus 50, that is 95. Divided by our new sample space of 112. Or our conditional space. So from that, that is now 95. So 95 over 112. Our answer here is 0.84821. Or this can also be written as 84.821% if you would be multiplying 100% here. Okay, so that is conditional probability. But what if, guys, for suppose that instead of us having the values of the number, just like in this case, what if, for example, that in our problem, we are now given the probability and not really the number of events? So with that being said, we cannot make use of this equation any longer. So what is now our new equation? Okay, so if I would now be, let's say, multiplying this equation here by 1. So if I am to multiply it by 1, so meaning that, of course, it will not change. But what if I will now change this one in a fraction that this is now equal to 1 over sample space divided by 1 over sample space. Again, this is still 1. That is still 1. But the thing is, of course, this is identical. So 1 over s divided by 1 over s, that is now, that is still equal to 1. So meaning that nothing has changed in this equation. But if I am now to multiply these values to our green equation here, our new equation would now be, so n time, the number of the intersection of A and B divided by the number of S. So by the way, I am referring to the number of S here. So all divided by the number of event B or the condition divided by the number of S. Okay. And from that, if we would now be simplifying this is actually equal to the probability of A in intersection with B. And this is now equal to the probability. So as you can see, number of events divided by the number of sample space. So this is now equal to the probability of B. So from that, guys, our new equation would now be equal to the probability of A given B is equal to the probability of the intersection of A and B divided by the probability of B. So as you can see, the only difference between this equation and this equation is that instead of just counting the number of elements in total, just get its probability. Okay? So in our sample problem here, for married couples living in a certain suburb, the probability that the husband will vote on a bond referendum is 0.21. The probability that the wife will vote on the referendum is 0.28. And the probability that both the husband and the wife will vote is 0.15. What is the probability that at least one member of the couple will vote, a wife will vote given that her husband will vote, and the husband will vote given that his wife will not vote? Okay, so once again, our new equation would now be this equation here. So with that, guys, I will now refer to the given as. So for the first probability here, so this is now the probability that the husband will vote on a bond referendum. Okay, so by the way, guys, for those of you who do not know what a bond referendum is, so I'm with you guys. I do not even know what that means. I'm just here for the probability. So di ko din po alam yan kung ano yan. Di ko na po aalamin. Wala pa po akong asawa, kaya hanggang dyan lang po muna tayo. No? So anyway, so we are only concerned with the probability here. So from that, for the first one, the probability that the husband will sign is equal to 0.21. Okay? So the probability that the wife will vote, so the probability that the wife will vote is equal to 0.28. Okay? And the probability that both the husband and the wife will vote is 0.15. So since we will be getting the probability that both of them will sign, this is now given by the equation, the probability of, since both of them will sign, that is the intersection of H and W. Okay, so from that, this is now equal to 0.15. Okay, so for the first problem here, so A. So what is now the probability that at least one member of the couple will vote? So if we are now to discuss about at least one member of the couple will vote, so is this a conditional probability in the first place? So just because that this is included in the video entitled conditional probability, it does not really necessarily mean that this is also a conditional probability. And in the first place, if you would be looking at this, or if you would be encountering this in your exam, the question will not indicate that it is under conditional probability. Of course, you should know. So in here, at least one member of the couple will vote. So meaning, guys, that this is included for letter A, because of course the husband is one member of the pair, as well as the wife. So if you are thinking that this is basically equal to PH, or the probability of H plus the probability of the wife, so actually you are correct. However, we still have an intersection here. So if you can remember our lecture from the last video on the additive property, or the addition property of joint events, so we must subtract here the redundant, and by redundant we are referring to their intersection. Okay, so in other words, that for letter A here, we are just getting the probability of the union between husband and wife. Okay? So once again, this equation here was already derived the last time, or in our last lecture, and this is now its formula. Okay, so as a review, suppose that we have, let's say, this Venn diagram here. If this is the husband and this is the wife, and from that, guys, this is now the intersection of husband and wife. So from that, guys, if we are just to get the union, so for the probability of H, we would now be getting all of this. And as for, let's say, the probability of the wife, we are now getting this area here. And as you can see, that there is a redundant area here at the middle. So as you can see, it is shaded both red and blue. So from that, guys, it is shaded both red and green, I should say. So from that, we must subtract this, of course, or we must subtract the redundant, of course, and that is now the probability of the intersection of husband and wife. Thus, our equation here. So again, this is not concerned with conditional probability. So this is still additive property of probability or joint events. So substituting known values, this is now equal to 0.21 plus 0.28 minus 0.15. So from that, the probability of the union of husband and wife is now equal to, so this is once again 0.21 plus 0.28 minus 0.15. So 0.21, 0.28, 0.15. Our answer here is 0.34 or 34%. Okay, so that is now for letter A. So again, that is for letter A. So I will just be writing the answer here, 34%. Okay, so let me erase this first. Okay, so what about for letter B? Okay, so for letter B, what is being asked here is, what is the probability that the wife will vote given that her husband will vote? As you can see here that we now have a condition. Thus, this is now a problem of conditional probability. So if we are to write this in conditional probability, so what is the probability that the wife will sign given that her husband will also sign? So that is now our formula, or that is now our condition. So this is equal to the probability of their intersections divided by the probability of the condition. So PH. So substituting known values, this is now equal to 0.15 divided by what is PH, or the probability of the husband signing or voting, that is now 0.21. So 0.21. So from that, this is 0.15 divided by 0.21. So this is now 5 over 7 or 0.7143 or 71.43%. Okay. So this is now for letter B. So what about for letter C? So for letter C, we are now getting the probability that the husband will vote given that his wife will not vote. So from that, what is the probability that the husband will vote in the condition that his wife will not vote? Okay? So from that, this is now equal to, his wife will not vote, so meaning that that is W complement. Okay? So from that, this is now equal to, so P times the intersection of husband and wife divided by the probability of the condition. So the condition here is that the wife will not sign. Again, why is it complement here? Because it is indicated here that it will not. Okay? So the wife will not sign. And since our value here of 0.28, the wife will sign. So it means that we are getting the opposite. Okay, so if you would be looking at our data, we do not have P, W prime, or the complement. So we do not have our complement here. However, if this is 28%, meaning that the remaining from the 28% will now be its complacent. So again, in a total of 100, if 28% will be deducted by it, so meaning that that is now 72%. So from that, guys, the complement of 0.28 is equal to 0.72. Or in other words, that is basically equal to 1 minus 0.28. Okay, so that is now 0.72. So if you would be adding 28% and 72%, that should be equal to 100%. So that is for its complement. So substituting known values here, this is now equal to, so what is now the probability of husband and wife? That is 0.15. So 0.15. So we would now be dividing this by the complement of the wife signing. Or in other words, what is now the I mean, the condition here is that the wife will not vote or will not sign. So our sample space here is 0.72. So 0.72. So from that, this is now equal to, look at the calculator to your left, 0.15 divided by 0.72. That is now equal to 0.208 or 20.83. So 20.83%. Okay. So that is now for our lecture.